Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're looking at the limit as h goes to 0 of cosine of this whole shebang, square root of 4 plus h minus 2 over h. So notice one of the things that we can do right off the bat when we're working with a problem like that is that we can pull the cosine outside of our limit and we just focus on the other stuff. So we have this nasty looking limit left over, and this is the part that's going to cause us so much trouble. So in fact, I'm going to highlight it because we're going to do something a little bit out of the ordinary here in order to solve this particular problem. Now, normally you'd look at that and you'd say, okay, well, I got to get rid of some h because right now we have some weird things going on. We got a 0 over 0. If we just plug in 0, for h going to 0 in there, and we got to work around that somehow. However, what we're going to do is we are going to use what we know in this case about functions and derivatives. So if we had our function as the square root of x, and I'm going to rewrite this also as x to the 1/2, we will need to use both of them. And we take the point a is equal to 4, then notice what happens is that if we rewrite this a little bit, I'm going to start with what we have originally, 4 plus h minus 2 over h. I'm going to rewrite this just a little bit. So I'm going to leave the initial stuff alone, 4 plus h, and I'm going to change our second term here into the square root of 4 all over h. This thing right here should look to you like a derivative using our definition of a derivative. In fact, it is the derivative of our function at 4 when our function is square root of x. So given the fact that we have our function is equal to square root of x, or x to the 1/2, we can actually use what we know about working with powers. So our derivative of x is going to be bringing our power down, subtracting 1 to get our new power. So 1/2 x to the negative 1/2, which implies when we plug in the number 4, because we are looking for the derivative at 4, we have 1/2 times 4 to the negative 1/2. I'm going to rewrite this just a little bit because remember when we have a negative in the exponent, that means we're actually popping that into the denominator. I'm going to rewrite it once more. 4 to the 1/2 is really square root of 4. Let me clean that up just a little bit because it looks gunky there. And square root of 4, as we know, is 2. And so we end up with f prime of 4 is the number 1/4. So putting that together with what we know already, when we take the limit as h goes to 0 of cosine square root of 4 plus h minus 2 all over h, we're actually looking at the cosine of 1/4 right there. So using what we know about the derivative and the definition of the derivative is very handy in a problem like this. Thank you for listening.